In this lesson, we will learn how to read and write ratios. So a ratio is a comparison of two quantities. So if we were to look at this set of shapes, we have a couple of circles, we have some triangles, we have some squares. And so if we wanted, or if we were going to talk about comparing the squares to the circles, we would say that there are, for every 4 squares, there are 2 circles. You can see that written in words down here. For every 4 squares, there are 2 circles. So the ratio of squares to circles is 4 to 2. We can write it like this. We can write it 4:2, or we can also write it 4/2. But it all means the same thing. It means that for every 4 squares, there are 2 circles. Now this is comparing a part within a part of the whole set, right? So we're comparing this part and this part. We also can compare a part to the whole. So looking at the whole set of shapes, we could compare the number of triangles to the total shapes. So for every 3 triangles, there are 9 total shapes. And so the ratio in this case then would be written 3:9, or 3:9, or 3/9. So in this lesson, we're going to continue to explore how we both read and write ratios. So let's look at this first example. It says there are 2 bran muffins and 1 blueberry muffin. You can compare the number of one type of muffin to the number of the other by division. And this is, again, comparing quantities. In this case, the quantity of bran muffins to blueberry muffins. So to compare the number of bran muffins to the number of blueberry muffins, you would write them as a ratio. So the number of bran muffins to blueberry muffins, well, we know that there are 2 bran muffins and there is 1 blueberry muffin. So in this case, in the ratio, the first term would be 2 because it's the number of bran muffins, and the second term would be 1 because that's the number of blueberry muffins. So we would say that the ratio of the number of bran muffins to blueberry muffins is 2:1. And now we have our little friend down here reminding us that the 2 quantities that you're comparing form the terms of the ratio. And we talked about the terms. The first term of the ratio is the first quantity in the comparison, and the second term is the second quantity. And you have to make sure that you write them in that order. And then we have our other little friend over here telling us that the ratio 2:1 tells us that there are 2 bran muffins to 1 blueberry muffin, or there is 1 blueberry muffin to 2 bran muffins. So we're just comparing those quantities. Now, if we were going to switch the quantities around, and we were going to compare the number of blueberry muffins to the number of bran muffins, then we would write them like this. So now our first term is the number of blueberry muffins. So the number of blueberry muffins was 1. And our second term is the number of bran muffins. And the number of bran muffins was 2. So we would say that the ratio of the number of blueberry muffins to the number of bran muffins is 1:2. And our friend down here reminding us that the ratio 1:2 tells us similarly that there's 1 blueberry muffin to 2 bran muffins, or there are 2 bran muffins to 1 blueberry muffin. All right, so let you try this now. The comparison that we're going to be making is looking at these pennants. we can see that there are some blue pennants and there are some yellow pennants. And so let's look at the first problem. It says the ratio of the number of blue pennants to the number of yellow pennants. So we're comparing blue to yellow. And I almost like to make a little notation above where I'm going to put my terms, because remember that order of the numbers in ratios is very important. Okay, so look now and think about what the ratio would be that you would write comparing blue pennants to the yellow pennants. Okay, so we saw there were 2 blue pennants and there are 5 yellow. So we would say the ratio of blue pennants to yellow pennants is 2 to 5. And now let's come down here and fill this in. So the ratio 2 to 5 tells us that there are blue pennants to yellow pennants. Well, there are 2 blue pennants to 5 yellow pennants, and there are yellow pennants to blue pennants. Fill in our and we can see that there are 5 yellow pennants to 2 blue pennants. Okay, I'm going to let you try number 2. This time they're switching the ratio that we're looking at things. So this one says the ratio of the number of yellow pennants to the number of blue pennants. Think about what your ratio would be and then see if you can predict what the blanks would be in this phrase. All right, so comparing yellow pennants to the blue pennants. Hopefully you saw that there were 5 yellow pennants for every 2 blue pennants. So the ratio was 5 to 2. And this tells us that there are 5 yellow pennants to 2 blue pennants, and that there are 2 blue pennants to 5 yellow pennants. Now, the examples that we've looked at so far give the actual quantities, right? So we had the actual quantities of muffins, and we had the actual quantities of pennants. But a ratio need not give the actual quantities compared. And we're going to look at some of these types of problems. So let's look at this type of problem. It says the manager of a sporting goods store set up bins of baseballs and lacrosse balls for sale. There are 2 bins of lacrosse balls and 3 bins of baseballs. Each bin has an equal number of balls. So we know that there's an equal number of balls in each bin, but the ratio does not give us the actual number of balls. We could say that there's 2 bins to 3 bins, or 2 to 3. This would be our ratio. So it doesn't give us the exact number of balls, but it gives us the ratio of the bins. So the ratio of the number of lacrosse balls to the number of baseballs. So again, order is important. Lacrosse was listed first and baseball was listed second. So we need to list 2 bins for lacrosse and 3 bins for baseball. So the ratio would be, or the ratio of lacrosse to baseballs is 2 to 3. If we switch that order and we looked at the ratio of the number of baseballs to the number of lacrosse balls, then it would be 3 to 2. And again, don't be afraid to use some notation to help you keep the order of the numbers straight, because order does matter. Now we can use part-whole models to show a ratio. Let's look at this first problem. It says Jim cuts a piece of wood 24 centimeters long into 2 pieces. The shorter piece is 7 centimeters long. Find the ratio of the length of the shorter piece to the length of the longer piece. So we need to find the ratio of the length of the shorter piece to the length of the longer piece. Okay, so how are we using a bar model to show us this? Well, we can see that the total length is 24 centimeters. We know one part of that. We know that part of that is 7. So to figure out the missing piece, we would need to subtract. And so 24 minus 7 is 17. So that missing side length is 17. Now we can make our ratio. So the length of the longer piece of wood is 17 centimeters. And so we can write the first length needs to be the shorter side. The second length needs to be the longer side. So it would be, the ratio would be 7 to 17. All right, so let's practice this together. This problem says a concrete mixture is made up of 3 parts of water, 4 parts of cement, and 5 parts of sand. Find the ratios of, the first one says the amount of cement to the amount of water. So again, order matters. So for A, we know we're going to be comparing cement to water. So how many parts of cement? There were 4. And how many parts of water? 3. So our ratio for part A would be 4 to 3. 4 parts cement to 3 parts water. Now in part B, it says the amount of sand to the amount of the concrete mixture. So the amount of sand to the amount of concrete mixture. So we can find the part of sand. We have 5 parts sand. And now we need to find the amount of concrete mixture. Well, this whole part is, all of those parts together give us the concrete mixture. So we would have to add the water plus the cement plus the sand to find the total concrete mixture. So 4 plus 3 is 7, plus 5 is 11. So our ratio would be 5 to 11. So this is an example of a part to part, right? The cement was 1 part of the total. The water was another part of the total. And the second one we looked at is a part whole. So the sand was a part, and the concrete mixture was the whole thing altogether. So it was a comparison of the part to the whole. All right, why don't you try this one? It says there are 20 animals in a pond. Of these animals, 7 are frogs, 8 are fish, and the rest are tortoises. Find the ratio of the number of frogs to the total number of animals, and B, the number of fish to the number of tortoises. Why don't you find those ratios, pause the video while you do so, and then check back to check in on your thinking. Okay, so some of you might have thought through this using a bar model. And so let's look at this one together. So if we have our total number of animals is 20, and it said we had 8 fish. So this part of the bar model is represented to be 8 fish. And here are our 7 frogs. And it said the rest were tortoises. And so if we combine 8 and 7, we see that we have 15 little creatures over there, meaning that this missing bar would be 5. So 5 tortoises. So now we can write our ratios. So if we have the number of frogs to the total number of animals, well, frogs represents 7, and the total number of animals was 20, so we would have 7 to 20. And part B says the number of fish to the number of tortoises. So the number of fish was 8, and the number of tortoises was 5. So the ratio of fish to tortoises would be 8 to 5. Again, remembering that order is so important. So to make little notes to yourself to make sure you get those numbers listed in the correct order. Part A, you probably noticed, was a part to whole. We were looking at a part of the set and comparing it to the total amount. And part B was a part to part, where we were looking at 2 parts within the set. In this lesson, we learned about ratios. We learned that ratios is a comparison, or are a comparison of 2 quantities. We can have a part-part ratio, or we can have a part-whole ratio. In a part-part, we're looking at 2 parts within a set, and in a part-whole, we're looking at a part of the set compared to the whole set. In this case, we really used, or in this lesson, we really focused on using the colon in notation and writing the ratios. And we talked about how we would say or read those ratios when listed in number notation.